Welcome to Brain Vision.
Hey everyone, this is question number 72 in chapter 14. In this problem, we're given that we have a steel ring with an inside diameter of 2.5 inches at 20 degrees Celsius. It's going to be warmed to fit onto a brass shaft that has an outside diameter of 2.502 inches at 20 degrees Celsius. We're asked to find A, the temperature the ring should be warmed to fit, and B, if both are cooled, what temperature will the ring slip off the shaft? Okay, so starting with part A, this is just going to be linear expansion. We have our original length of 2.5 inches and we need it to be 2.502. So we can start out with our linear expansion equation, delta L equals alpha L naught delta T. And then we rearrange for delta T. Delta T equals delta L over L naught alpha. And our delta L in this case, we are changing it by 0.02 inches because we start at 2.5 and we need to go to 2.502. So now we can just plug in our numbers. Delta T equals L naught is 2.5 inches. Alpha for steel is 1.2 times 10 to the minus fifth C degrees to the minus 1. And then, like I said, our delta L is 0.002 inches. And that gives us a temperature of 66.7 degrees C. But remember, this is a temperature change. We just solved for delta T. So now we need to add our original. So T equals T naught plus delta T. So that is 20 degrees Celsius plus 66.7 degrees Celsius, which gives us 87 degrees Celsius if you round. It would be 86.7, but we can round to 87 degrees Celsius. So that's what you would need to heat it to. So now we go on to part B. If both are cooled, what temperature will the ring slip off the shaft? So now we apply linear expansion to the shaft and the ring because they're both going to be changing. And we're solving for L. We have our originals, and the equation for that is L equals L naught 1 plus A alpha, delta T. So in this case, we need our change in temperature to be the same, our delta T to be the same, and our lengths, our L's, need to be equal to each other as well, because that's when the ring would be able to slip off if they're the same size, or the ring is just the same size or a little bit bigger. So we set our L naught or our LS equal to our L brass and solve. So if we plug in this equation for our L's, we have and distribute. Well, I'll write all of it out for you guys. We have L naught B 1 plus alpha B delta T equals L naught S 1 plus alpha S delta T. And then we distribute those and you get L naught S plus L naught S alpha delta T is equal to L naught B plus L naught B alpha delta T. And then we are solving for our delta T, like I said, because we're asked for the temperature. So if we rearrange and solve for delta T, we get L naught B minus L naught S over L naught S alpha S minus L naught B alpha B. And we can plug in our numbers. Delta T, that was correct. Delta T equals L naught B minus L naught S. L naught B was 2.502 inches minus 2.5 inches over L naught S, 2.5 inches times alpha S, which is 1.2 times 10 to the minus fifth. C degrees to the minus 1 minus L naught B 2.502 times alpha B, which is 2 times 10 to the minus fifth. And if you plug that into your calculator, carefully do the top and the bottom separately first, you get delta T is equal to minus 100 degrees Celsius. But this is our delta T, this isn't our original T, so we need to do T naught plus delta T. And that is going to give us 20 degrees plus negative 100 degrees. This is all in Celsius, which is going to give us a temperature equal to minus 80 degrees Celsius. And that is the temperature that the ring would start to slip off the shaft.